Today we are going to start section 5.5, inequalities involving absolute value. Absolute value inequalities with the less than symbol are the first type that we'll look at. The inequality absolute value of x is less than 3 means that the distance between x and 0 is less than 3. So x is greater than negative 3 and x is less than 3. So the solution set is for all numbers x such that negative 3 is less than x is less than 3. When solving absolute value inequalities, there are two cases that we need to consider. In case 1, the expression inside the absolute value symbols is positive, and in case 2, the expression inside the absolute value symbols is negative. The solution is the intersection of the solution of these two cases. Let's look at an example. In example 1, solving absolute value inequalities with the less than symbol, we have the absolute value of n minus 8 is less than or equal to 2. As I stated, we have two different cases that we need to consider. In case 1, we have n minus 8 is less than or equal to 2. And in case 2, we have to make what's inside the absolute value symbols negative. So we'll put a negative outside the quantity n minus 8 is less than or equal to 2. Let's solve case 1 first. We'll add 8 to both sides, and we end up with the solution being n is less than or equal to 10. In case 2, it's a little bit more difficult, but when you get used to it, you can skip this step. The first thing that we're going to do is we're going to distribute the negative. So negative n minus 8 is the same as, if you think about it this way, having a negative 1 in front of the n minus 8 is going to end up being negative n plus 8 is less than or equal to 2. Now, we want to go ahead and get rid of the negative 1, and we could do this at any point that we wanted to. We could do it later if we wanted, or we can do it now. We divide both sides by negative 1, and that gives us n minus 8 is greater than or equal to negative 2. So basically the only thing that we did is we flipped our symbol and we changed what was on the other side of the inequality to a negative. We could have also solved it like this. Negative n plus 8 less than or equal to 2. We're going to subtract 8 from both sides, and we get negative n is less than or equal to negative 6. And then we divide both sides by negative 1, and when we do that, it flips our symbol. We get n is greater than or equal to positive 6. So either way you do it, you're going to come out with the same answer. For some of you, this way will be easier because that's the way we've done it previously. So our solution set is going to be for all numbers n such that 6 is less than or equal to n is less than or equal to 10. So it works out a lot like the compound inequalities that we were working on before, where we're going to take the smallest answer, n is greater than or equal to 6, and we're going to put that variable on the opposite side, which means that we have to flip our symbol. So we have 6 is less than or equal to n, and n is less than or equal to 10. When we graph that, we have closed circles on the 6 and the 10, and the part that's in between would be the intersection, and that would be our answer. Another example under the less than inequalities is the absolute value of 2c minus 5 is less than negative 3. Now, what's inside the absolute value symbols, 2c minus 5, cannot be negative. Because if you recall, anytime you have something inside absolute value, it's going to equal a positive number, right? So what's in there is not going to be negative. So it's not possible for the absolute value of 2c minus 5 to be less than negative 3. Therefore, there is no solution, and the solution then is actually the empty set. Let's look at an example together. In guided practice 1, we have the absolute value of x plus 8 is less than 16. We need to solve our two different cases. So we have x plus 8 is less than 16, and we have negative x plus 8 is less than 16. So we'll go ahead and solve this one first, and we'll subtract 8 from both sides, and we get x is less than 8. In the other one, let's go ahead and distribute, and we get negative x minus 8 is less than 16. We're going to add 8 to both sides, and we get negative x is less than 24. We'll divide both sides by negative 1, and we get x is greater than negative 24. So our solution, we're going to look at the one with the smallest answer first, and we're going to flip that around. So we have x such that negative 24 is less than x, and x is less than 8. On a number line, and I've run out of room for the number line, but I'll try to put it up here just so we can see it a little bit. On the number line, we have negative 24, and we have 8, and this time we have open circles. This is going to be a bit messy, and everything in between the two is going to be what is their intersection and therefore their solution. So everything less than 8 and everything greater than negative 24. Now it's your turn to try one on your own. In self-check 1, we have the absolute value of r plus 1 is less than or equal to 2. Now the number line got in the way there, and so you can just kind of disregard that number line. For example B, you have the absolute value of 5v plus 3 is greater than negative 9. Actually, that should be less than negative 9, not greater than negative 9. So you'll need to look at the example that we showed in example 1 to see what you do when you have negative 9 on the other side there and how you're going to answer that one. The second type of absolute value inequality that we will discuss is the ones with the greater than symbol. The inequality absolute value of x is greater than 3 means that the distance between x and 0 is greater than 3. So x is less than negative 3 or x is greater than 3. So once again, we've got the or here instead of the and. The solution set is for all numbers x such that x is less than negative 3 or x is greater than 3. We still must consider the two cases that we considered in our first example, and that is that the expression inside the absolute value is positive, and in case 2, the expression inside the absolute value symbol is negative. Let's look at example 2 together. In example 2, we have the absolute value of 2k plus 1 is greater than 7. Once again, we need to solve two different cases. So we have 2k plus 1 is greater than 7, or the negative quantity 2k plus 1 is greater than 7. In the first case, we'll subtract 1 from both sides, which leaves us with 2 times k is greater than 6. Divide both sides by 2, and we get k is greater than 3. In the second case, we need to distribute our negative, so we get negative 2k minus 1 is greater than 7. Remember, if it helps you, consider that negative to be a negative 1 when you distribute. Once we've distributed the negative, we'll add 1 to both sides, which leaves us with negative 2 times k is greater than 8. And then we'll divide both sides by negative 2, and we get k is less than negative 4. Remember that we need to flip that symbol when we divide by a negative. So our solution is k for all numbers k such that k is greater than 3 or k is less than negative 4. Because we have greater than and less than symbols, our dots or circles are going to be open. So k is less than negative 4 is going to be an open circle on negative 4 with the arrow pointing to the left because that's where the numbers are less than negative 4. And k is greater than 3 is going to be an open circle on the 3 with the numbers to the right because that's where the numbers are going to be greater than 3. Also, in example 2, we have an additional example where we have the absolute value of r minus 6 is greater than or equal to negative 5. The solution set here is different than with the less than symbol where it was an empty set when we had a negative answer or negative on the right side. The solution set here is for for all numbers r such that r is a real number. Because the absolute value of r minus 6 is going to be greater than or equal to 0, because it's always going to be a positive number. So it's always going to be greater than or equal to a negative number, such as -5. Let's look at an example together in Guided Practice 2. Guided Practice 2, we have the absolute value of k minus 4 is greater than 3. Once again, we need to solve two cases, so we have k minus 4 is greater than 3, or the negative of k minus 4 is greater than 3. So we're going to add 4 to both sides. We get k is greater than 7. We're going to distribute our negative, so negative k plus 4 is greater than 3. Subtract 4 from both sides. Negative k is greater than -1. Divide both sides by -1, and we get k is less than 1. So our solution set is going to be for all numbers k, such that k is less than 1 or k is greater than 7. On the number line, we'll use open circles again. And on the 1, we'll have an open circle. And on the 7, we'll have an open circle. The numbers greater than 7 are going to be to the right, and the numbers less than 1 will be to the left. And that will be our graph answer. For the second example in Guided Practice 2, we have the absolute value of -2c minus 3 is greater than -4. Because of this -4, we know that anything inside the absolute value is going to be greater. So our solution set will be c such that c is a real number. On the number line, that just means we're going to have everything colored in, because it means any real number is going to be a solution. Now it's your turn. In self-check number 2, I want you to solve the problems in A and B. And then I also want you to try the one at the bottom. It's a little harder, but I think the information that you've learned in this lesson should help you to do that. And also, if you think back to when we solved equations that were a little bit more difficult in Chapter 2, we had to do these where we had something very similar to this, where we had a numerator and a denominator in an equation. So think back to that, look back in your journals and see if you can give yourself some information for some help on that. Also, make sure you show your work on the back of your notes and your answers on your notes for me.